All right, we are starting our next unit on quadratics, and before we do that, we are going to talk a little bit about complex numbers. So complex numbers happen when I have a real number and an imaginary number. So what are imaginary numbers? Well, this is when I have solutions where I have to square a negative. So we let I represent the square root of -1, and if I were to square both sides, that means that I squared equals -1. This will be important later on for simplifying expressions. So if inside my radical I have a perfect square, I can rewrite that as a number times I. If I even have a non-perfect square, I can simplify that radical and rewrite them with I. I is always outside of the radical. So again, with complex numbers, your real number comes first, your imaginary numbers come second. So let's do some practice simplifying first. So if I have the square root of -4, that's the same thing as having the square root of 4 times the square root of -1. I know the square root of 4 is 2, and we are letting the square root of -1 be I. So this is 2I. On B, this is the same thing as the square root of 4 over 25 times the square root of -1. The square root of 4 over 25 is 2 over 5, and the square root of -1, again, is I. On C, I've got a whole string of these. I know the square root of -49 would be 7I, minus the square root of -9 would be 3I, plus the square root of -36 would be 6I. I can combine these like terms just like I could if there was any other variable involved. So 7 minus 3 plus 6 gives me 10I. Doing some more stuff with our complex numbers, so combining like terms and simplifying, I need to first make sure everything in my expression is written in terms of I. So on this first set of parentheses, there's nothing for me to do. On the second set, the 2 is not going to change, but this square root of -8, that is 2 square root of 2I. The 2 square root of 2 comes from 8 having a factor of 4. 4 is a perfect square, so that can come out of my radical. The other 2 is still inside. So looking here, 6 and 2 are my real numbers. Those go in front. That gives me 8. And then 3I and -2 square root of 2I, these coefficients don't match, so I can't combine them as is. So I'm going to leave them as 3 minus 2 square root of 2 and leave the I on the outside. On to part E, I'm squaring a binomial, which means I'm multiplying it by itself, so I have to FOIL. 3 times 3 is going to give me 9. 3 times 2I gives me 6I. 2I times 3 gives me 6I. And 2I times 2I is 4I squared. Now I can combine my like terms. Currently, I don't have anything to combine with the 9. 6I and 6I gives me 12I. Then I have 4I squared. And remember, I squared equals -1. So this is the same thing as 4 times -1, which becomes -4. So combining my real numbers that have to go in front, 5 plus 12I is my final result for example E. On to F, I'm foiling again. I'm going to get 16 minus 40I plus 6I minus 15I squared. So that's going to give me 16 minus 34I, and then I've got -15 times -1 because I squared equals -1. So that becomes plus 15, combining my real numbers in front. 31 minus 34I is my final answer. Now we are going to look at I to different powers and see if we can find a pattern. Now, anything to the first power is just itself. So I to the 1 is I. I squared, we already know, is -1. Now, I'm going to use my exponent rules to rewrite I to the third. Remember, when you multiply like terms, you add their exponents. So I to the 1 times I squared is the same thing as I to the third. So that's I times -1, which is -I. If I move on to I to the fourth, I could rewrite that as I squared times I squared, which would be -1 times -1, which is +1. Moving on, I to the fifth, that would be the same thing as I to the 4th times I to the 1st. So 1 times I, which is just I. I to the 6th, I could rewrite that as I to the 5th times I to the 1. I to the 5th is I to the 1 is also I, so this is I squared, which we know to be -1. I to the 7th, I could say I to the 6th times I to the 1, so that's -1 times I, or -I. I to the 8th, that could be like I to the 4th times I to the 4th, which is 1 times 1, 1. So if we look back at what we have here, we can see a pattern. I've got I, -1, I, +1. I, -1, I, +1. This cycle is going to keep repeating for every multiple of 4. So to find I to any power, all you need to do is divide your exponent by 4 and look at the remainder. So for I to the 20, for example, that divided by 4 is 5 remainder 0. So that means I'm going to go through that whole cycle 5 times. And if my remainder is 0, that means I've ended at the last stop on the way. So I to the 20 is +1. If I have I to the 27th, I'm going to divide 27 by 4, and that will give me 6 remainder 3. So that means I'm going to go through the whole cycle 6 times and end on the 3rd stop. 1, 2, 3. I to the 27th is -I. I to the 33rd, if I divide 33 by 4, I get 8 remainder 1. So that means I go through the whole cycle 8 times and then end on the 1st stop. So I. And then if I had I to the 97, 97 divided by 4 is 24, remainder 1. So again, going through 24 times, ending on the 1st stop in my cycle, so I to the 97 is going to be I. The last thing we're going to talk about today with our imaginary numbers is when we're rationalizing a denominator. So remember, I means the square root of -1, and we don't like square roots in our denominators. So if you have I in your denominator, you need to rationalize it to get it gone. So the way we do this is we multiply not by the reciprocal, but what we call the conjugate of your denominator. What that looks like is you take your two terms, those stay the same. All you're changing is in between, whether it's going to be addition or subtraction. So on this first example, I have 7 minus 6i, so my conjugate will be 7 plus 6i. And anything I do in the bottom, I have to do in the top. So in the numerator, I am going to distribute that 12i to both things, and that's going to give me 84i plus 72i squared. In my denominator, I'm multiplying two binomials, which means I'm going to have to FOIL. So I'm going to get 49 plus 42i minus 42i minus 36i squared. If I simplify in my numerator, I'm going to have 84i plus 72 times -1 because I squared is -1. So when I rewrite this as my final answer, remember your real number has to go in front. So it's going to be -72 plus 84i. Onto my denominator, I currently don't have anything to combine the 49 with. My middle terms cancel. And then I've got -36i squared, which again is -1. So this is going to become 49 plus 36, which is 85. I no longer have I in my denominator, which means I'm done. I rationalized. Let's practice this one more time. Here, my denominator is -9 plus 10i, so my conjugate will be -9 minus 10i in the top and the bottom. And I'm going to have to FOIL twice on this one because I have double binomials. So in the top, I'm going to get 27 plus 30i minus 72i minus 80i squared. In my denominator, I'm going to get 81 plus 90i minus 90i minus 100i squared. So simplifying in my numerator, I've got 27, 30i minus 72i gives me -42i. minus 80, again, I squared is really negative 1. In my denominator, I'm going to have 81. My middle terms cancel, minus 100 times negative 1. So my numerator, this becomes 27 plus 80, so 107 minus 42i over 81 plus 100. And I no longer have I in my denominator, so I'm done. And this concludes our introductory notes to imaginary and complex numbers.